Welcome back, students, to Day 2 notes on our unit, The Gas Laws, where we will be discussing Boyles's and Charles's laws. Just a reminder that you can pause the video at any time as you write things down. You are encouraged to rewind for better understanding. After today, you will be able to explain the effect on gas properties using Boyles's and Charles's laws. You will also be able to calculate an unknown pressure, temperature, or volume by solving algebraically. First, let's discuss Boyle's law, which deals with pressure and volume. Robert Boyle was the first person to study the pressure-volume relationship of gases. In 1662, Boyle proposed a law to describe this relationship. If you look at the graph on your screen, you can see that as pressure increases across the x-axis, the volume of the gas is forced to decrease. So as pressure increases, volume decreases. If you'll remember, this is what we call an indirect relationship. As one variable increases, the other variable will decrease. They go opposite directions. For a given mass of gas at constant temperature, the volume of a gas varies inversely with the pressure. Boyle's law, which deals with volume and pressure, or pressure and volume, can be summed up mathematically. We can simplify this relationship by the formula P1 times V1 equals P2 times V2, or pressure 1 times volume 1 equals pressure 2 times volume 2. P1 and V1 are the pressure and volume before the change. P2 and V2 are the pressure and volume after a change. Where P1 and P2 are pressure in any unit, such as atmospheres, kilopascals, or millimeters of mercury, but they must match. V1 and V2, volume in any unit, usually liters or milliliters, but they must match as well. Let's take a look at a Boyle's law example. It says a gas has a volume of 30 liters at 150 kilopascals of pressure. What is the volume of the gas at 0.252 atmospheres of pressure? You will notice that the two pressures are in different units, 150 kilopascals and 0.252 atmospheres. We are going to have to convert so that they are measured in the same units. The first thing we need to do to solve this problem is to list our knowns and unknowns for our variables. We've got pressure 1, which is equal to 150 kilopascals. Volume 1 is equal to 30.0 liters. Pressure 2 is given to us as 0.252 atmospheres. And volume 2, that's our unknown, that's what we're asked to solve for. The problem here is that our pressure 1 and our pressure 2 are not measured in the same units. So we will have to convert using some of the information that was given to us on our day 0 notes. If you remember, 101.3 kilopascals from the day 0 notes is equal to 1 atmosphere. So we can use this to convert. Once we convert, we find out that 150 kilopascals is actually equal to 1.5 atmospheres. Now you can see that both pressures are measured in atmospheres, and we can go ahead and do the problem. Our second step is to write the formula for Boyle's law. Pressure 1 times volume 1 equals pressure 2 times volume 2. Now that we have our pressure both in the units of atmospheres, we can substitute all of our knowns into the equation for Boyle's law. 1.5 atmospheres is our pressure 1. Our volume 1 is 30.0 liters. And we're going to set that equal to our pressure 2, which is 0.252 atmospheres, times our volume 2, which is our unknown. All we need to do to solve now is to take 1.5 times 30 and divide by 0.252. When we do that, the atmospheres will cancel out, and we will be left with volume 2, which should be measured in liters. You can see algebraically that our volume 2 is 180 liters. Let's see if this makes sense. You guys, if you take a look at our pressure 1, it was 1.5 atmospheres. If you look at pressure 2, it has been decreased to 0.252 atmospheres. According to Boyle's law, as pressure is decreased, the volume of the gas should be allowed to increase. And you can see that as we go from volume 1 to volume 2, we increase from 30 liters to 180 liters, which follows right in line with what Boyle was trying to say. Let's move on to Charles's law, which deals with temperature and volume. Jacques Charles studied the effect of temperature on volume of a gas at constant pressure. If we take a look at one of Charles's graphs, you can see that as temperature is increased across the x-axis, the volume of the gas must increase. That means as one variable, the temperature is increased, the volume must increase as well. If you remember from the day 0 or day 1 notes, I can't remember at this time, that's called a direct relationship. As one variable increases, the other variable increases as well. In 1787, Charles proposed a law to describe his observations. For a given mass of gas at constant pressure, the volume of the gas is directly proportional to its temperature in Kelvin. Remember, temperature must be measured in Kelvin. Let's take a look at a Charles law example where we deal with temperature and volume. We can simplify this relationship by the formula volume 1 over temperature 1 equals volume 2 over temperature 2, where V1 and V2 are volume in any unit, usually liters or milliliters, but they must match. We may have to do some conversion. Temperature 1 and T2, T1 and T2, are temperature, which always has to be measured in Kelvin. Recall that to convert Celsius to Kelvin, you just add 273. Let's look at an example of Charles's law. A gas has a volume of 4.0 liters at 27 degrees Celsius. What is its volume at 153 degrees Celsius? Do you notice anything wrong with this problem? They give us both temperatures in Celsius. We should know that temperature has to be measured in Kelvin for these problems, so we're going to have to convert. The first thing we need to do is to list all of our knowns and unknown variables. So we've got volume 1, temperature 1, volume 2, and T2, temperature 2. Volume 1 is 4.0 liters. Temperature 1 is 27 degrees Celsius, but we have to add 273 to convert it to Kelvin. So now our answer is 300 Kelvin. Our volume 2, that's the volume that it should change to, that is our unknown. And temperature 2 is 153 degrees Celsius, but we must convert that to Kelvin by adding 273. So our temperature 2 is 426 Kelvin. The next thing we have to do is write down the Charles's law formula. So we've got V1 over T1, volume 1 over temperature 1, equals volume 2 over temperature 2. Now we will substitute our knowns and unknowns into our formula. So volume 1 is 4.0 liters. Temperature 1, which we converted to Kelvin, is 300 Kelvin. And we're going to set that equal to volume 2, which is our unknown, over temperature 2, which is 426 Kelvin after the conversion. To solve this algebraically, all we're going to do is cross multiply 4.0 liters times 426 Kelvin, and then divide by the 300 Kelvin. And that will give us our answer for volume 2, which is 5.7 liters. Let's see if this makes any sense according to Charles' law. Charles's law says that as the temperature of a gas is increased, then the volume of that gas should also increase. It's a directly proportional relationship. If we take a look, the temperature is raised from T1 at 300 Kelvin to 426 Kelvin. So in theory, the volume of the gas should go up. And we just found out that the volume is increasing from V1 of 4.0 liters to 5.7 liters. So this falls right in line with what Charles was trying to say. Any questions? You'll have to ask me tomorrow. Now you should complete worksheet 2. Please remember that when dealing with problems that deal with Charles's law, that the temperature has to be converted to Kelvin by adding 273. Realize also that when dealing with Boyle's law, that the units for pressure have to be the same, either both in atmospheres, both in millimeters of mercury, or both in kilopascals. You can find the conversions for those units on your day 0 notes. Good luck with the worksheet, and I'll see you tomorrow.